Hi, in this sequence of videos I'm going to be going over the AQA Core 1 January 2012 exam paper. I'm going to split the videos into three parts. The first part of the video will be an opportunity for you to try the question. Once you've had a go, and if you feel like you need a little bit of extra support, then you can watch the hint section of the video where I'll give you some tips as to how you can go about answering the questions. Finally, the last part of the video will be an opportunity for you to either check your answers or work through the solution with me, and I'll go over the full answers to the question. Can I suggest to use these videos if you can try and be as active as you can throughout, so that means have a go at the questions as you go through. If there's at any point of watching the videos you feel like you can finish a question off, then pause the video and have a go at doing that. Okay, so question number one, the first part of this video then, I'm going to give you the opportunity to try the question, so if you'd like to pause the video now and have a go. Okay, well done if you managed to have a go at that. For the next part of the video I'm going to give you a hint as to how you can go about answering the question. So we've got the point A that's got coordinates 6, -4, and point B that has coordinates -2, 7. We're given that the point O has the coordinate 0, 0, so point O is the origin. We're going to show that the length OA is less than the length OB. So if you think about the distance from the origin to this point A, and how you can work that distance out, and also the distance from our origin to point B, and what you want to do is you want to compare those distances together. Okay, part B asks us to find the gradient of AB. So again, it would be useful for you to sketch a diagram and mark on point A and mark on point B, and then decide what the change in y is and what the change in x is, and use that to decide what the gradient of AB is going to be. Part 2 asks us to find an equation of the line AB in the form px plus qy is equal to r, where p, q and r are integers. So from part 1 of part B, you'll already know what the gradient is. We also know a point that the line passes through, so that will give us enough information to write down an equation, and then we need to manipulate the equation so that we've got it in this form here, where p, q and r are integers. Part C asks us to tells us that the coordinates for point C are k0, and the other bit of information we're given is that the line AC is perpendicular to the line AB. So that means that the gradient that we found in AB, we need to find a gradient that's perpendicular to that. Once we know this, we should be able to finish off the rest of this question. Okay, those are my hints, so if you'd now like to pause the video and see if you can have a go at this question. Okay, the last part will be me going over the full solution to this question. So starting with part A, we need to show that the length of OA is less than the length of OB. What I'm going to do is, and this is what I would encourage you to do, is just draw a quick sketch so you can see clearly what's going on. So over here I'm going to have my set of axes, and on my axes I'm going to mark point A, which is going to be 6, -4, so that's going to be around there somewhere. So that's 6, -4. Okay, and I'm also going to mark point B, which is going to have coordinates -2, 7. Up here I'm going to have -2, 7. Okay, so that's point A and that's point B. We need to show okay, we're going to have a line over here, and we're also going to have this line here. Okay, so we need to show that the length OA, this length here, is less than the length OB. So hopefully you'll have spotted that we can use Pythagoras to work this out, because this here is a right angle triangle and this here is a right angle triangle. So this is going to have a length of 6 and height of 4, so we can do 6 squared plus 4 squared, and we can square root that. So our length OA is going to be equal to 6 squared plus 4 squared square rooted, and if we simplify that, that's going to be 36 plus 16, so that's going to be 52. So the length OA is going to be the square root of 52. Okay, the length OB, well, that's going to be this distance here, so that's going to be 2 and 7. So we're going to have the square root of 2 squared plus 7 squared, and that's going to be 4 and 49, which gives us root 53. Okay, and this shows that the length OA, this one here, is less than the length OB. So we can write, therefore OA is less than OB. And there you go, so that's part A. Okay, part B, for the first part of part B, we need to find the gradient of AB. So again, I can draw a quick line to show that the line AB is going to look like this here. So that blue line there is our line AB. Now, the gradient of that line, well, we want to do the change in y divided by the change in x. So the change in y, well, that's going to go from 7 to -4. So the change in y is going to be -11. And we want to divide that by the change in x. Well, the change in x, it's going to be 2 and another 6. So that's going to be 8. So the gradient of AB, which I'm going to call m, is going to be equal to -11/8. Part 2, we want to find an equation of the line AB in this form here, where P, Q and R are integers. So I can start off by saying, well, I know that, well, there's a couple of ways of doing this. We'll use this formula here where we've got y take away y1 is equal to m times x take away x1. Another way of doing this is that you could put it in the form y equals mx plus c, and substitute your m in and substitute in one of these coordinates, and then work out what the c is, and this is essentially doing the same thing. So I'm going to choose this set of coordinates here. So y take away y1 is going to be this here, so that's going to be y take away -4, which is y plus 4, is equal to m, which is -11/8, and over here we're going to have x take away that coordinate there, which is 6. Okay, so I can expand this out, but before I do that, because I know that I want everything to be in integers or in whole numbers, I'm going to multiply everything by 8. So that's going to give me 8y plus 32 equals, and that's going to be negative 11 times x minus 6. Okay, and then, so just come over here, I can finish this off because that's going to be, and if I expand the brackets, I'm going to have 8y plus 32 is equal to negative 11x plus 66. Now we've almost got it in this form, so I want to have a number of x plus a number of y is equal to r, so I'm going to add 11x to both sides, so that's going to give me 11x plus 8y, but I'm also going to subtract 32 from both sides, so that will turn that to 0, and that's going to be equal to, and I want to do 66 and subtract 32 from it, and that gives me 34. Just as a quick check, there isn't a common factor for each of these numbers, so I think that that is going to be in its simplest form. So our solution is 11x plus 8y is equal to 34, where p is 11, q is 8, and r is 34. Okay, finally part C. In this question we're finding the line, well, we're told that the line AC is perpendicular to the line AB. So this was the line AB. So AC must pass through A and also must be perpendicular to that line as well. So if I just draw a line, let's use red this time. Okay, so we're doing something that's going to be perpendicular to this line and passing through this line as well. So it's going to look something, whoops, we use a straight line, and it's going to look something like this here. Yeah, so that's a right angle there, it's perpendicular to the line, and it's actually going through point A as well. And what we're looking for is we're looking for point C, which has coordinates k0. So k0 basically is going to be a point that is going to lie on the x-axis. Okay, so the y coordinate is 0, so it's going to lie on the x-axis. So what we're looking for is that point there, which we've called point C. So that's what it's going to look like graphically. So let's see how we can go about working this out. Well, the first thing I need to know is I need to know what the gradient of this line is going to be. Well, I knew the gradient of this line was negative 11/8. So the gradient of this line is going to be the negative reciprocal of that. So I'm going to have a new m, and this time my m is going to be the negative reciprocal of that there, which is going to be 8/11. Okay, I can now use the same method that I did before, because I can say that we'll use this formula here. So that's going to be, and I know it passes through the point A, so it passes through this set of coordinates here. So I've got y plus 4, yeah, so it's y take away negative 4, y plus 4 is equal to an 8/11, and we're going to have x subtract 6. There you go. Yeah, so we can see the similarities between what we've got here and here, but this time we've got a different gradient that's perpendicular to this one. Okay, so tidying that up then, so this time I'll multiply through by 11, so that's going to be 11y plus 44 is equal to, and I'm going to expand, so this is going to become 8, but I'm going to expand the brackets at the same time, so that's going to be 8x take away 48. There we go. So just tidying this up a little bit, I'll subtract this 44 from both sides, so I'm going to have 11y is equal to 8x subtract 92. Okay, so I don't need to go any further than this. I know that point C has coordinates k0, so that means I can substitute k in for my x and 0 in for my y. So if x is going to be k and y is going to be 0, that's going to be 11 times 0, which is 0, equals 8 times x, which is k, so 8k take away 92, and that tells me 8k must be equal to 92, which means k is going to be equal to 92 over 8, and if we simplify that, k is going to be equal to, and 4 is a common factor of both of these, so that's going to be 23 halves. Okay, so our solution for this is going to be k is equal to 23 halves, or we could have written that as 11.5. Okay, there you go. Hopefully you found that useful. Thanks very much for watching. I'll see you again next time.